Good morning, everybody. So yesterday we were discussing about hardenability. Hardenability is definition I have. Hardenability is ability to become hard. It is the susceptibility of material to become thoroughly hard. And the sentence which I have dictated to you, hardenability is related to depth and distribution of the hardness throughout the cross section. Make underline and star mark to the statement. Hardenability is related to depth and distribution of the hardness throughout the cross section. Means if distribution of hardness throughout the cross section is good, we can say that part is having good hardenability. But we have discussed that hardness depends upon presence of martensite and it should dominate to the other phase. Logically, if amount of martensite is more than 50%, then only it can dominate. So if you take the cross section of the component and if you go on checking the percentage of martensite point to point, the area where the percentage of martensite is 50% or more, that part is considered as a hard as per thumb rule. So this is decided by the interpreters. Means more than 50% martensite is present, we'll consider that is a hard part. But if percentage of martensite is less than 50%, that part will not be considered as a hard. Now, suppose you are the customer. I am the owner of company or as a metallurgist in one of the foundry or in one of the heat treatment shop. You are a regular manufacturer of some of the component of different size and shape. And you as a customer want to know this is the component and I am using this and this quenchant. If I will carry out the hardness, whether this part will be thoroughly hardened or not. So this is the question of customer to the metallurgist. I repeat, I have this component, whether this component will be thoroughly hardened or not. Now how without checking we can tell whether it will be thoroughly hardened or not. So some experiments are carried out based on the concept of hardenability. And the technocrat or the metallurgist or the owner of the company through his team will carry out one of the experiment and without testing his part, I say without testing the part of customer, report can be given, yes, if you use this material, this size and this quenchant, your part will be thoroughly hardened. And now you decide what to keep this size and which quenchant is supposed to be used. So these are nowadays very important requirements in the industry. So because if blindly you are carrying out the hardening process, taking any quenchant, and you may not get the good hardness and there may be failure of the component. Okay, that's why the method for finding the hardenability must be studied. Before we find the method for hardenability, 1 minute. Before we find the method for hardenability, the concept which I told, the part can be considered as a hard when at least 50% martensite is present. So you must know, every time we are not going to take the cross section, prepare the specimen and see under microscope. Without microscope, this judgment is given. But for that purpose, some data is required with you. You have to check hardness of 50% martensite. Means you have to prepare the sample and check in the microscope. Definitely you have to locate where is the 50% martensite, and now after making that part is kept under, after making the mark, that part is kept under hardness testing machine, and then hardness will be measured and some. So this is the hardness of 50% martensite. Definitely if martensite is 60%, that will show more hardness accordingly. and if martensite is less than 50%, it will show accordingly. So first aim is to find out the hardness corresponding to 50% martensite. So I repeat this once again. You have to take the specimen, make the hard, take the cross section, measure or locate the area. So some good quality microscopes, our simple microscopes available in the lab may not judge it. So high quality scanning electron microscopes are required, and through that microscope you have to locate the area where 50% martensite is present. That you have to make mark with the help of marker, and then same component you have to shift to the hardness testing machine and measure the hardness of that point corresponding to 50% martensite. For example, the figure which I have drawn here, I have shown that this part is thoroughly hardened because 50% martensite is present at center, but it may not happen every time. Now for that purpose, there are two experiments corresponding to measurement of hardenability. These two experiments are, first is Grossman's critical diameter method, and second is Jomini and quench test. Just write down the title: experiments carried out for measurement of hardenability. First is Grossman's critical diameter method, and second is Jomini, Jominy, Jomini and quench test. These are the two tests used for measuring the hardenability. Let us see one by one. Now let us see with example. Suppose I am the person, metallurgist, who is going to decide the hardenability. Customer will come to me. Customer will give me the drawing, sample drawing, and he will tell, hey sir, this is the part which I am going to make, and this is the material, and this is the quenchant. Please tell me whether this part is thoroughly hardened. If not, up to what depth it will be hardened. Now I will follow the Grossman's method. What I will do? First, I will prepare number of samples of the same material which is used by that customer, because I will take the name of material from him. Then he has produced simple bars on the lathe machine. Simple thing. Before that, what material is going to use by that customer, that material's hardness of 50% martensite is find out. That data is required. And suppose this is the plot where I put the sample. This is hardness 0 to 5, 10, 20 RC units or BHN units, whatever may be. And suppose this is the hardness value corresponding to 50% martensite. Any value, suppose 25 RC. We are least bothered about it. I only know that this hardness value is corresponding to 50% martensite. Means if 50% martensite and remaining 50% bainite, perlite, whatever may be present, so that corresponding hardness is this value, X value. Okay. Now, Grossman suggested the method. According to Grossman, select the number of bars, start preparing the bars and start quenching it. So, I want to give information to that customer. What is the depth of hardness? What is that dimension up to which your part will become hard? So I will start suppose with bar of 10 mm diameter. This is one rod of 10 mm diameter. Okay. Now this rod is made of same material which is used by customer for making his components. This bar I will take, heat, soak and quench in the quenchant which is used by the customer. And after doing this, the hardness value is measured at the surface to center. How? You have to take the cross section in this way. Here I will show. You have to take the cross section and put your hardness tip. There is a diamond or ball indenter. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At different points, hardness is measured. And that hardness is plotted here. In this way. So at surface hardness value, suppose this is 25, 10, 50. So at this point hardness is around 40 something, and then at center hardness is maybe 30, and again at surface it is 40. Now I can say that this part is thoroughly hard. Even you find deep here, at center, martensite is more than 50%. At center, martensite is more than 50%. That's why at center, hardness value is 35 or 40. Because if martensite is 50%, hardness value is 25. I hope you are getting. Okay. It means I can say that this bar of 10 mm diameter is thoroughly hard. Now, same experiment is repeated. Second sample of little higher diameter. This is 12 mm diameter bar. Same experiment is carried out. At that time, you observe in this way. Again, increase at center, hardness will be reduced than this hardness, no doubt. But even I can say that it is thoroughly hardened. At center, hardness is around 31, 32, which is more than 25. Then I will carry out the experiment. At 13 mm. I got this curve. Even I can say that this part is thoroughly hardened. I am not finding the correct dimension. So, I will come back, but for your information, I have directly selected 15 mm, suppose. 15 mm. And I got this curve. What is meaning of this? Hardness at center is less than 25. Means at center there is no 50% martensite. It is less than 50% martensite. So my aim is to find out that particular dimension where there is a exact 50% martensite at the center. Are you getting my point? My aim is to find out that dimension of rod where there is exactly 50% martensite at center, and then trial and error 2-3 samples, 13.5, then 14.5. In this way, 3-4 samples are once again tested, and Actually, it may not be correct 14, but for easy understanding, I have taken 14 mm. It may not be a round figure. It may be 14.2, it may be 13.9, anything. But for your understanding, I have taken it round figure. And for 14, I got this graph. What is the specialty? This is 14 mm diameter bar, which gives at center correct 25 mm value. This 25 mm hardness is corresponding to 50% martensite. That record I am having. It means without checking this sample below microscope, I can say that for this bar there is 50 martensite at center. And now this 14 is my critical diameter. That's why the method is Grossman's critical diameter method. What is meaning of critical diameter? 14 mm, that diameter where part is thoroughly hard. Critical diameter means that diameter for which your part is thoroughly hard. More than that, you will not get hardness thoroughly. But less than it, all parts are thoroughly hardened. So this is called as critical diameter. Now what means what we supposed to do and what we supposed to tell that customer? This is important question. Grossman has decided this method, but now our turn. We have to give writing report to the customer because he has asked what is the depth of hardness. So I can write the report and I can tell to the customer that if you use the steel of this material and if you use the quenchant which I have used during the experiment, your part will show thoroughly hardness up to 14 mm diameter. Remember, then what will be the depth of hardness? Depth of hardness is equal to, now somebody reply, unmute and reply. Depth of hardness is equal to what? Samruddhi.
Yes, sir.
Please answer my question. I find out 14 mm diameter which can be thoroughly hardened. Means this is a 14 mm bar. This is a 14 mm bar. I am quenching it. Then I can say that this is thoroughly hardened. Means at center 50% martensite will be produced for 14 mm bar. Now tell me what is the depth of hardness? Huh? Give stress to your brain, you will get answer. How much? Please answer. Samruddhi.
Sir, at 25% we can say that it is low.
You are not getting my question. My question is 14 mm is the diameter. 1/4. I am saying that this part is thoroughly hardened. My question is, what is the depth of hardness from surface to center? 7 mm.
Sir, half of the diameter.
Critical diameter divided by 2 is the depth of hardness. Are you getting my point? Because quenchant is touching from all the sides. So 7 mm from this side, 7 mm from this side, 7 mm from this side. From all sides, effect of quenchant is up to 7 mm only. This is the outcome of the experiment. And this is the judgment which I supposed to tell to that customer. I can say that if you use this steel and this quenchant, you will get 50% martensite at 7 mm where your quenchant is touching. You take any shape, If you take round shape, 7 mm from all sides. If you take square shape, 7 mm from all sides. Up to that depth only, your part becomes hard. This will be my judgment and result, which I will give to the customer. This is called as depth of hardness. Now, before we take the illustration, I will go to second experiment and then I will give illustration. So you find this experiment is little lengthy. So Jomini has made it easy. So before I explain it, please draw these figures. This will not ask in the exam. Please remember, it will not be asked to explain UK, explain Grossman method, etc. This is, I am giving the extra information for interview and oral. You must know as a technocrat how to find out the critical diameter. Please draw this. You must know the names. Procedure you need not. That's why I am not dictated. Please draw this. Now I am taking meeting attendance. If I make directly, attendance will be recorded with your name, how many minutes and seconds you have attended. Every record is available in this Google meeting. Just by one click, I'm getting one Excel sheet, name of the student, and number of minutes and seconds he attended, and how many times he is leaving the room. That's why now it becomes easy to record the attendance. Where the screen is visible? Somebody reply.
Yes, sir.
Are you going to see this Excel sheet?
Yes, sir.
In this way, attendance will be recorded. So from last 17 minutes, how many students are present? So please convey this message to your friends. In this way, minute to minute record is made. You might have read the decision from Supreme Court about the final year exams. Now there is no option for final year students. So somebody of them might have shown the casual approach in last 4-5 months. Now they have to appear for exam. Similarly, if government will decide to conduct the exam of first year, second year, third year without conducting classes in actual classrooms, based on these online classes, your exam may be conducted. And at that time, those who are having good attendance, they will get additional benefits. Please convey this message to your friends. Anything may happen. Now, second method, Jomini and quench test. Sorry, you write here this line in this way: hardness corresponding to 50% martensite. Please write this statement. I will read. This line is hardness corresponding to 50% martensite. I repeat once again. This line you have to write hardness corresponding to 50% martensite. This will not also be part of theory, but as a extra experiment, we are going to conduct it during practicals. Fortunately, if pandemic situation will be cleared and it become normal, you will be in college. At that time, the focus will be given on experiments first, because yet we have not conducted any experiment. So at that time, in syllabus, this is not there, but we have instruments and we are going to conduct as a content beyond syllabus. And at that time, I can show you. Even you can Google it and you can enjoy this. It is available on the YouTube also. Okay. So I will explain now how to find out the depth of hardness by Jomini method. This Jomini and Grossman, who are names of technocrats, scientists, who have decided this method. If any of person from your class will find out such method, that name will be given. So there is an opportunity. Now, Grossman method name is critical diameter and method is also critical. 10 to 15 rods you have to machine, manufacture and carry out the experiment 10-15 times to find out the correct diameter. So that is accurate method. Okay, but this method will be little precise and it will also give corresponding to same depth of hardness, and fast method and easy method. What Jomini has done? Jomini has used only one single bar. This bar is 4-inch long. And 1-inch diameter. Four-inch long and 1-inch diameter. This is the specimen prepared by Jomini. Means now when customer will come to me and customer will ask me, this is my drawing and please tell me depth of hardness for this specimen. Any complicated drawing customer may have. Then what, as a technocrat, I will ask the question, please tell me the type of material and which quenchant you are going to use. So same type of material, I will machine the bar. Customer's component is different. Same materials bar I have prepared. Same way, Jomini also prepared the same material number of bars. Grossman. And Jomini also now follows same method. But he produced only one bar of 4-inch diameter and 4-inch length and 1-inch diameter. So this bar is prepared by Jomini of the same material. Now, he has prepared one setup. Why the name is end quench? End means at the end of bar. Jomini was doing it thoroughly. In this bar was dipped into the temperature bath, or this quenchant bath, quenchant bath. Then quenchant will touch all sides, and then he was measuring the hardness. Jomini has suggested little simple method. Jomini want to find out what is effect of quenchant from the surface where it is touching. I repeat my statement once again. Jomini want to find out the effect of quenchant from surface up to inside. Wherever the quenchant touch, from that surface up to how much distance inside the quenchant is making the effect. What is meaning of quenchant is making the effect? Means fast cooling rate given by quenchant. Means up to what depth the cooling rate is so fast that 50% martensite is produced. So that is find out by just touching at the end. For that purpose, one nozzle, the arrangement or setup or fixture is having one nozzle, and through that nozzle water will be forced. Now this bar is fixed at the top with the help of some screw, etc., and half-inch distance is kept below this bar. And as soon as water will come, it is adjusted in such a way that water will form the umbrella in this way. I hope you are getting my point. Water will not directly go above this. Fixture is made accordingly, and pressure of water is adjusted accordingly so that it will touch. Now I am saying water. If water is used as a quenchant, if that customer is using brine, use brine here. Whatever quenchant is used, use this quenchant here. And now this part is not kept as it is here. It is first heated to the austenitic range, soaked there for sufficient time, immediately taken out from the furnace, and then fixed in this way. Assume that this is furnace. Assume that this is fixture. In this picture, this part is hold and water is touching from bottom. So water arrangement is ready already. Only this bar you have to take from the furnace and fix in the fixture. Then you are supposed to wait. Initially, in few seconds, you observe this bar red hot, totally red hot. And then as it is in atmosphere, bottom side it is in contact with quenchant, but more than 95% part it is in air. Quenchant is making effect. We have to find out up to what distance it is making the effect. Now, this complete part which is open to atmosphere, it will be normalized, because normalizing is air cooling. And we have to find out how much length of part. Now I am using the word length because it is length. How much length of the part becomes harder. So after doing this for few minutes, once it will become cold, after cooling, you have to take it. After taking, you have to use some polished paper, remove the scale, and this bar is kept on the hardness testing machine horizontally in this way. See here how I am showing. I will put this on the graph paper directly. Here, this is hardness value, length, length of the spacer. Now, I said this bar is taken from this fixture, polished. Okay, and then you have to measure the hardness from quenching end to air end. This is quenching end. Means this part you have to make marking, and this is air end. And in this way you have to make markings. If I measure the hardness, now imagine this is two-dimensional figure. Imagine 3D. So here, and I am observing from top. Okay. So if I measure the hardness at this point, suppose if this is the value on this scale, suppose it gives 40 value. If I go to next point, hardness value drop to 38. If I go to third point, this is first point, second point, third point, hardness value drop to 35. If I go to next point, fourth point, I got hardness value suddenly drop. For this point, I have measured the hardness, suddenly drop here, 20. And from here, I got this one, almost incline, not straight line, but almost a straight line. For all these points. Try to understand this graph. I mark this point. I repeat once again, this is quenching end. This bar is taken and put on hardness testing machine. So in the same way, there is a pad on hardness testing machine. Assume that this is your component. Just see now. This is your component, and this hardness testing machine is having the tip or diamond. So this is quench end and this is air end. So I measure the hardness here at this point. I got 40 RC. Immediately I go to next point, just by 1 mm distance. I got 39. Immediately third point, I got hardness 38. The distance between each point is 1 mm, not more than that. Fourth point, 38. Now fifth should be 37 or 36. But fifth point, I got 20 hardness. Sudden drop, 30, 40, 39, 38, and direct 20. So at this point, I got hardness 20. And hereafter, whatever points I go on measuring the hardness, I got 19, 20, 19, 20, same way. What is meaning of this? Meaning of this is from quenching end at this distance, fifth point, effect of quenchant is there. And suddenly, after fifth point, in the air, majority part is in the air. That's why it is normalized and produce the perlite. Indirectly, if I measure if I see the phase at this end, this is quench end. So 100% martensite, 95% martensite, 90% martensite, 85% martensite, directly 20% martensite. And thereafter only 10-20%, or here again 0% martensite. Means what? After particular distance, the complete part is under the air cooling, and effect of quenchant from quenching end up to certain end is limited. And now we have to find out this distance. Suppose this distance is 5 mm. Suppose this distance is 5 mm. Means at end hardness martensite is 100%. 1 mm 95, 2 mm 95, 3 mm 90, 4 mm 89, and 5 mm directly 20% martensite. Means sudden drop in hardness. So up to 5 mm quenchant has made effect. This is the concluding remark of the Jomini. What Jomini said, when you carry out this experiment, when you heat in the austenitic zone and end quench, this quenchant can make effect up to 5 mm length if you use this quenchant and this material. Now, this is the outcome of Jomini. And now Jomini will prepare the report for the customers. Depth of hardness is equal to now tell. Who will tell the answer now?
5.
Correct. Absolutely correct. So where quenchant is touching, up to what mm depth effect is made, that is your depth of hardness. How easy the experiment, Dan Grossman? And now, once I am the customer now, I will go in the role of customer. I know that my material for this quenchant, I am getting depth of hardness 5 mm. So now let us see the illustration. Before that, you draw this. Right here, quenchant, air end. And these values of hardness, sudden drop. Now, what is the separate or indirect thing here? Length of hardness is treated as depth of hardness. So here you can write length of length up to which %50% martensite is produced equal to depth of hardness equal to 5 mm. Length up to which 50% martensite is produced equal to depth of hardness equal to 5 mm. This is just for an example. It may be 3.5 mm, it may be 7.6 mm, any distance. For easy understanding, I have taken this. Now, let us see the illustration. May I erase this? Please reply.
Wait, sir.
Okay. Dimensions you write 1 inch diameter, 4 inch length. See Jomini specimen. Or
Yes, sir. Over.
10 minutes are remaining. I will give illustration. Now, whenever I ask question, you have to immediately unmute and answer. Okay. Suppose depth of hardness equal to 3 mm. This value I have obtained by either Grossman or Germany. And now I will draw one specimen or component. You have to answer whether it will be thoroughly hardened or not. This is one hollow cylinder. This is a hollow cylinder. 1 minute. This is one hollow cylinder. Hollow means it is open from both sides. Outer diameter is 30 mm. Inner diameter is 18 mm. This is my component. And I have used some quenchant. And I got the report from Germany or Gross. Hardness is 3 mm. Now this cylinder I will hard, means I will heat in the austenitic zone, soak, and I will dip into water now or water quenchant. Completely I will dip, and after carrying out complete hardening process, please answer whether this part will be thoroughly hardened or not. Think and give answer. Take 1 minute. My question is whether this cylinder will be thoroughly hardened or not. Depth of hardness is 3 mm. Yes? Anybody willingly?
Yes, sir.
And please justify.
Yes.
Who is answering? Who is giving answer?
Sir, Dhanashri.
Dhanashri. Correct. Your answer is correct. Please justify so that others will also understand.
Sir, that thickness is 6 mm.
Correct. Because it is
And-
symmetrical. By default, I said it is hollow cylinder. So it is symmetrical. So this is 6 mm, this is 6 mm because it is 18. So 18 minus this 30 minus 18 is 12. So this is 6, this is 6. Now.
And from both side, the quenchant is effect. So that's why.
Correct. Absolutely correct. As this is a hollow cylinder, when you are dipping in bath, quenchant is going from inside also, touching to this surface. Quenchant is touching to this surface. Quenchant is touching to this surface. quenchant is touching to both these surfaces. We know that 3 mm is depth. How much this is? This is 6. So 3 mm from this side, 3 mm from this side. Means 6 mm. Means I can say that this part is thoroughly hardened. So don't go by dimensions 18 or 30. In this way, you have to find out. This is the significance of depth of hardness. This cylinder is now thoroughly hardened. Let us take answer you right, thoroughly hardened. Second example. This is one square cross section part. You can say square prism. I have taken cross section and it is hollow. Again it is hollow. And outer square diameter is 50 by 50 and inner square is 20 by 20. And Jomini and Grossman method has given for same material 5 mm as a depth of hardness. And now my shape is different. Answer whether it is thoroughly hardened or not.
It is not thoroughly hardened, sir.
Correct. Who is talking?
Omkar Kale.
Omkar. Correct answer. Justify.
The whole length of the square is 50, then
Okay.
minus 20,
Okay.
then remaining.
This will be
15
15.
Yes,
Okay.
sir.
15.
Yes.
So from this side quotient is touching, this side quotient is touching. Okay. So how much effect it will make? 5 mm.
5 mm. 5 mm.
So this side 5 mm, this side 5 mm. It becomes 10, but this distance is 15. Means thoroughly not hardened. I will show the band of hardness. You will understand. Hatching part means hardened. The part which is hatched is hardened and this gap is not hardened. Are you getting my point? So the significance, how to use the significance of depth of hardness, 5 mm from both the sides, means we can say that part is not thoroughly hardened. And suppose I want to make it thoroughly hardened, this distance I have to maintain 10 mm only. In that case, I have to increase the size of 20 mm square hole. Are you getting my point? Please answer.
Yes, sir.
Okay. So this is significance of depth of hardness. And this is called as case depth. Remember this word, case depth, because from tomorrow's class, they are going to start this type. Case depth equal to 5 mm. Another name of depth of hardness and depth of hardness is used up to what mm? Case depth. The part is hard. So this is a technical word. So technocrats are using. What is case depth of your hardness? This 5 mm is the case depth of hardness. And now in industry, there are many cases where you don't want thoroughly hardness. Now see, I am telling contradictory. I repeat my statement once again. In industry, there are many requirements where you don't want part to be thoroughly hardened. You want to make it hard up to certain depth only. Example, gears, cams. So that part, what is need of it, we are going to explain in the next lecture. And the name of hardening is case hardening or surface hardening. So friends, significance of hardenability, how it is important, even it is not part of your exam. This today's lecture is very important because it is going to ask in interviews and orals. Oral, okay, then you can compromise with another questions. But such answers, if you give in the interviews, chances of selection are more. Okay, so we will stop here, and in next class we will start with case hardening. Thank you very much.